Welcome everyone. Let's get right into it. Today, we're unpacking how developers manage massive Python programs without letting the complexity completely spiral out of control. If you've ever wondered how real-world software scales seamlessly, well, you're in exactly the right place.
So think about this for a second. How do programmers avoid writing millions of lines of code entirely from scratch? I mean, writing a massive code base line by grueling line would literally take years. The room for error? Absolutely chaotic, right? There's got to be a better way. A trick developers use to scale up their work efficiently without losing their minds.
Okay, let's dive into this. Here is the roadmap for today's explainer. We'll start with why you need to organize your code, clearly define modules and libraries, and explore the three main types of modules. Then we'll cover how to import code, how to create your own user-defined modules, and finally, the magic of name main.
Section 1. Why organize your code? Escaping the chaos.
You know, when you're just starting out as a coder, you're usually writing scripts. These are short, simple sets of instructions focused on a single task, kind of like texting a friend when the pizza's ready. But as you progress, you start writing code. That's a much broader term. We're talking vast, interconnected systems here, like building an entire video game from the ground up.
And here is the catch. As programs grow, they inevitably become difficult to manage. What happens when a single script gets too big? Well, it becomes an absolute nightmare to read, debug, and update. But don't worry, this sets up the ultimate organizational lifesavers that Python literally built right into its core philosophy.
Section 2. Modules and libraries defined. The Python hardware store.
This brings us to modular programming. A module is really just a single .py file containing related tools, like functions, classes, and variables. Think of it as a single toolbox. A library, on the other hand, is a collection of several related modules grouped together to help with a specific task. So, if a module is a single toolbox, a library is... Actually, it's more like a massive hardware store full of toolboxes, sometimes hundreds of them, all working together for a common purpose.
Section 3. Three types of modules: built-in, third-party, and user-defined.
There are three main categories you really need to know to scale up your work. First up, built-in modules. These come pre-installed with Python. Take the random module, for instance. It lets you generate a random integer between 1 and 10,000 in a fraction of a second. And the best part? We don't have to write any of the complex underlying math to do it. Second, we've got third-party modules. Think NumPy for heavy-duty numerical computing or Pandas for data analysis. These are created by external developers. And third, user-defined modules, which are the ones you build yourself.
Now, to use those amazing third-party modules that don't come pre-installed, it just takes a super quick installation step using a command called pip. Typing something like pip install requests in your terminal literally reaches out to the internet, grabs that specific external library, and drops it into your machine so you can start using it right away.
Section 4. How to import code. Unlocking the tools.
Seriously, why reinvent the wheel when Python already built a perfectly good one for you? Here is the absolute most basic, fundamental way to import an entire module. You just use the keyword import, followed by the name. Bam. Import Math pulls the entire math module right into your program, handing you the keys to all its functions, like square roots and trigonometry.
But what if you don't like the default name, or you just want to save yourself some typing? We're programmers. We like efficiency. That's where our second method comes in. By using the as keyword, you create an alias. Import math as M means every time you want to use a math tool, you just hit the letter M instead of typing the whole word. It's a fantastic little shortcut. And finally, method number 3. Sometimes you just don't want to lug around the whole heavy toolbox. You just need one very specific tool. Using the from keyword, like from math import pi, pulls just that specific constant into your code. You don't even have to reference the whole module anymore. It's clean, it's precise, and it keeps your code incredibly efficient.
Section 5. Creating user-defined modules. Building your own tools.
Now, what's really interesting about this slide is it shows that once you master pulling in external tools, you're inevitably going to want to write your own. And creating a user-defined module is literally just writing standard, reusable Python code and saving it as a .py file. That's the whole shebang. If we make a file named my_math_calculator.py, we can define a constant called 0, write a couple of quick functions to add and multiply numbers, and boom, you've just built a module that you can import into literally any other Python program you ever write.
Section 6.
The magic of name main, Python's secret trick.
Okay, gather round for a little insider programmer knowledge. When you look at custom modules, you're almost always going to see this line. If dunder name equals dunder main. And dunder is just our shorthand for double underscore. Here's the trick. When you import a module, Python secretly assigns that module's name to a special variable called name. But if you run the script directly, Python sets that name variable to the string main. Why do this? Because it beautifully prevents all your functions from running automatically the second you import the file. It ensures your code only executes when you specifically want it to run directly. Pretty clever, right?
So we've covered the absolute chaos of massive code bases, the elegance of modules, how to import them, and how to build and protect your own. The sheer efficiency you gain by modularizing your code is staggering. It's a real game changer. So I want to leave you with one final thought to chew on. What will you build now that you have Python's entire toolbox right at your fingertips? Thanks for joining me on this explainer.